Hi students, good morning, a very good morning to all. So today we are going to do with the revision for very important chapter, that is chemical equilibrium. So as I told yesterday, so this is one of the chapter where many students have a lot of doubts. So we do with lot of questions, okay. So those who have forgot to subscribe our channel, so they can subscribe it, okay. So I am again introducing ourselves. So we are part of Brainiacs Classes. So we are located at Coimbatore, okay. So we have delivered almost 100 plus doctors in our past 4 years, with all from humble background and from average scores. So this is one of the very good platform where if you are passionate to become doctor, this is the right platform. And right now we are giving free lectures and revision classes for all the students, those who are not able to attend Neet coaching, and those who are preparing from home, for them it would be highly beneficial, okay. So all of you subscribe our channel. So every Sunday 4 p.m. we will come with one chapter for revision, and we will also upload this PDF in the YouTube. You can download it and make use of it, okay. So if you have any doubt, feel free to put it in the comment box, okay. So can we start it? Yeah, okay. So the first question, okay, the question given here is, first I will read it, then we will discuss its concept, then we will start explaining it, how to do it, okay. The question they have asked here is the Kc for the given reaction. The reaction is A2 plus 2B gives C plus 2D, okay. When questions like this comes, we can easily write it actually. We know that equilibrium constant Kc is concentration of the products divided by concentration of the reactants. So we can start writing by the fundamental equation Kc, okay. So we know that Kc is nothing but what? Concentration of the products, divided by concentration of the reactants, correct? This is the fundamental, okay. Now we apply the law of mass action and we will write it, okay. So here products are C and D. So as per law of mass action, what we are expected to do, we need to, if more than one products are there, we need to multiply its concentration, that is concentration of C into concentration of D, okay. And D have a coefficient 2, so in that case we should raise to that power, so D square divided by what it will come, sir? Concentration of A2 into what it will come? Concentration of B the whole square, because it has the coefficient, what? Coefficient as 2. You can see here, okay. You can see here its coefficient is 2. So whenever coefficient comes, that should be raised to power, it should come. For D also it comes like this. Now most of the students will stop the answer at this point, and maybe this option might be present in the option also, as especially as option 1. But please check, very important, please check, this equation is applicable only for gases. For solids and pure liquids, the concentration is always taken as unity. So if you are looking at the different reactants, it is a gas, okay, and B, it is also a gas, and C is also a gas, but D is a solid. So please remember, when solids are present, we need to mention there the concentration of a solid. So here D is the solid, so its concentration need to be taken as unity. Very important. If you have solids or pure liquids are there, its concentration needs to be taken as what? Unity. Why it is like that? Because its density will not vary. Why? Because its density will not change. So it's unity. So how the Kc will change to? What would be the new Kc, sir? So I can write the new Kc would be concentration of C, okay, into, so its value becomes 1, D is 1, then divided by what it will become? Concentration of A2, okay, there is no change because it is also gas, and concentration of B the whole square, okay. So do we have any option like that? Yes, option 2 looks the correct answer. So my answer is option 2. So please understand, in NEET exam, while you are doing problems, you may be in a hurry to solve the question. So you may miss out this point. So why I have taken this as unity? Please remember, I am writing here as an important point. So while you are doing the revision, all these points come to your mind. So concentration of solids and pure liquids are taken as 1. Okay, pure liquids are taken as 1. I hope you know the reason, because its density will not change. Density is a constant. Okay, so I hope it is clear for you. So can we switch to the next question? So I hope you understood how to apply this. Okay, so as a general form, we can write even this also. This is for students who doesn't know law of mass action. Suppose you have a reaction like this, AA. So this is a gas, and you have something like BB. Okay, and this is also a gas, and this is a reversible reaction, and you know that equilibrium is applicable only for what sort of reactions are reversible reaction. Then we say equilibrium is, when we say equilibrium is reached, the rate of forward reaction becomes equal to the rate of backward reaction, correct? Or we say, when, can anybody tell, when the concentration of reactants and products will not change once the equilibrium is reached. So we can say CC and you have DD. Consider a reaction like this is present. So for this is also gas. Let us assume this is also gas. This is also gas. So in this case, how will you apply Kc, sir? How will you apply Kc? Very simple. So when I am going to apply Kc, what you need to do? Concentration of the product. So concentration of the C. Okay. Concentration of the C. So what is its coefficient? Tell me, sir, what is its coefficient? Coefficient is also C. So C raised to C into concentration of D. Concentration of D. Okay. Whole raised to, what it will become? Again, coefficient is also D. Divided by concentration of A. Concentration of A. Concentration of A raised to A. Concentration of B raised to B. Okay, this is how generally you write Kc for a particular reversible reaction. Okay, so here also I mentioned the answer for you to get a clarity. If suppose my handwriting is not clear, you can make use of it. Okay, so I think it's very fundamental question. It can be expected for exam. Okay, yeah. So going to the next question. So first we will read the question and try to understand it. Very good question. So in which of the following does the reaction goes almost to completion? So what is the meaning of this question? They have given you different Kc values and they want to know for which particular Kc value the reactant maybe 90% or 99% gets converted to product, or almost to go to completion, but never it will go to completion. Why? Because we have an equilibrium constant. So equilibrium constant is there, means the reaction before completion might have reached what? It might have reached equilibrium. Okay, so I will say for generally for reactions how it is actually, then I will answer this question. So we can say generally, okay, how we can write? Generally we can classify reversible reactions into 3 types. Okay, generally we can classify reversible reactions reversible reactions into three. What is it based on? Based on the time at which the reaction attains equilibrium. Very simple, sir. ഇപ്പോൾ നമ്മൾ റിയാക്ഷൻസ് എടുത്തിരിച്ചു. സോ ഇഫ് യു ടേക്ക് റിയാക്ഷൻസ്, സം റിയാക്ഷൻസ് വിൽ അറ്റൈൻ ഇക്വിലിബ്രിയം മേ ബി വെരി ഇനിഷ്യലി. ഫോർ എക്സാമ്പിൾ, വെൻ മോസ്റ്റ് ഓഫ് ദ റിയാക്ടൻസ് ആർ ദെയർ ആൻഡ് ഓൺലി വെരി സ്മോൾ amount of products are there, at that point some reactions may attain equilibrium. There are some reactions when there are equal amount of reactants and equal amount of products are formed. At that point they will attain equilibrium. And there are other type of reactions where most of the reactants are converted to products, and at that point they may attain equilibrium. Okay, so based on that we can classify this into three. So let me say a reaction. For example, I am taking three different types of reactions. Okay, this is for your understanding. I am explaining this theory. So let me say A is converted to product B. A is converted to product B. Let me say at time t is equal to 0. At time t is equal to 0. Let me say this is present as 1000 units. 1000 mole per liter. This is its concentration. Okay, and unit of B, there is nothing is present, so we will make it as 0. So this is 1000, only reactants are present. Now at equilibrium, when equilibrium is reached, okay, so first case is where the reactants are more. So let me say 800 units are remaining here, and remaining 200 units are converted to product. So at this point I can say it has reached equilibrium. Once equilibrium is reached, now the concentration value, that is 800 or 200, does not change. It will stay like that. So at this point, if I put equilibrium constant Kc, it would be like 200, I can say 200 concentration of the product divided by concentration of the reactant, that is 800. So what it would be, I can say this is 1 by 4, or we can say this is 0.25, or I can say equilibrium constant Kc has got a value less than 1. Clear? So this is the first case where the concentration of reactants, I can write it here. In this case we can say concentration of, okay, I will put it in the bracket and write, at this point at equilibrium we can say the concentration of the reactants is greater than the concentration of the products. Okay, this is first type of reversible reaction. Now let's try to understand the second type. So in second type, what will happen, sir? Only difference is, let me say a reaction C giving you D. C giving you a reversible reaction, let me say D. So in the second type, let me say you have at time t equal to 0. You have again 1000 unit is present here and 0 unit is present here. Now at equilibrium, when equilibrium is reached, let us assume 500 units of this changed to product, and here also 500 units are formed. Okay, so at this point I can say very clearly here the concentration of the reactant is equal to concentration of the product. Correct? Because when equilibrium is reached, both of its concentration are same. So in this case, if you calculate Kc, what will happen, sir? In this case, if you calculate Kc, you can see 500 by 500 it will become 500 by 500. So the value will be almost equal to 1. So or you can say second type of reaction have Kc will be equal to 1. Correct? Now you can easily say what would be the third case. What would be the third case, sir? So in third case, what we can say? So suppose if I am taking a third case, like for example E, a reaction where E converting to F. Okay, so in E converting to F. Okay, so in third case, let me say here 1000 units are there at a time t is equal to 0. Here 0 units are present. At equilibrium, let me say only 200 units are remaining. 800 units have been converted to product. So it can be anything. Only thing is product greater than. So at this point, I can say one thing. When equilibrium is reached, the concentration of the reactant is what? Less than concentration of the product. Correct? So in this case, you can see if you define Kc value, surely concentration of the product is more and the reactant is less, and you are getting a value that is greater than 1, or you can say Kc is equal to 4. Okay, now you might have understood in which of the reaction might have goes to completion almost. So if you see here in the last type of reaction, only 200 units are remaining all converted to product, or I can say it has almost went to completion. So I can say in those reactions where products are more, we can say the reaction almost go to completion, and for them the Kc value will be very high. Whichever have the highest Kc value, in that case the products are more, very more, and the reaction has almost to go to completion. So our highlight point is which one? What is the point you should remember here? Tell me, sir. So those who have doubts, you can put it on the comment box. Okay, so the point to remember here is whenever the Kc value is high, it indicates that concentration of products are very high. That is reaction almost went to completion, but not completed. It's almost went into completion. What we can say in that case? Maybe 90% completed or 99.9% completed. Okay, so from the given options, tell me, sir, whichever has the highest Kc value. So when I am checking, Kc is 1000 here. Okay, you can see here it is 1000. Kc is 1000 here. Here it is 100. Here it is 10 power minus 2 less than 1, 10 power minus 3 less than 1. Don't need to consider 3 and 4. From these two, both of them have Kc value greater than 1. But among that, the highest Kc value is for this one. So I can say this has almost went to completion. So I can mark this as my correct answer. So 1 is my correct answer. So I hope you got a very good fair explanation. Good idea. Okay. Those who find difficulty in physics and chemistry, I will recommend Brainiacs classes. For a single reason, where we deeply into each of the concept to make it understand for even average students and make them score very good marks for physics and chemistry. And biology also we have very good classes, and physics and chemistry would be our highlight. Okay, don't even feel bad like, sir, we already went to some other institute, so how it is. You can even come to our institute for a single chapter as well. It's completely fine. So the purpose is, those who have a passion to become doctors, we are highly supporting those students, because they will do very much good to our society. Okay, so those students who are a passion to become a doctor, I will recommend Brainiacs classes as the perfect place for you to become doctors. Okay, shall we go to next question? Yep. So we have the next question in front of us. All of you please go through the question. Yeah, question looks simple. In a chemical equilibrium, the rate constant of the backward reaction is given as 7.5 into 10 power minus 4, and the equilibrium constant is 1.5. So the rate constant of the forward reaction is what they are asking. Okay, so let me explain you some background. Those who doesn't know the theory, very simple. So it's very simple. For example, I am considering a reaction. I am taking a reaction, let me say A to B. So I can write it like this. This means A will be converted to B. Okay. And the rate constant of this forward reaction, let me take it as Kf. Okay. Now let us assume this can happen in a reversible way. That means B can also be converted back to reactants. Then this will become what? A reversible reaction. So I can put the arrow now like this. Okay, like this. You can put the arrow like this. And for that I will put the rate constant as Kb. Okay. Now you have a forward reaction. After some time it will product will convert back to reactants. For that the rate constant is Kb. So forward reaction, the rate constant is Kf. So how will you write the rate constant fundamentally? So we know that from chemical kinetics chapter, the rate of a reaction, the rate of forward reaction can be written as, or the rate of a reaction depends only on reactants. Correct? So when forward reaction is happening, who is the reactant? I know A is the reactant and A is getting converted to product B. So I can write Rf is equal to Kf into concentration of A. Okay, concentration of the reactant. Now tell me, sir, when reverse reaction is happening, I can say B is getting converted to the product A. Now the reactant is B, sir. So how will you write the rate equation for the backward reaction? Tell me, sir. RB, that is the rate of the backward reaction, is equal to Kb into concentration of B. Kb into concentration of B. Now we know that at equilibrium, what happens? At equilibrium, what happens, sir? At equilibrium, we learned that fundamental definition says that at equilibrium, the rate of forward reaction, becomes equal to the rate of backward reaction. Whenever the forward reaction rate is becoming equal to the rate of backward reaction, we say the reversible reaction has attained equilibrium. Okay, Rf is equal to Rb. Now tell me, sir, we can substitute here. So for Rf, I can put it as Kf into concentration of A. Okay, equal to Rb would be equal to what, sir? Kb into concentration of B. Correct? Now I can rearrange it and write. So let me write Kf here and Kb to be on the denominator. So here Kb I am writing. So it becomes Kf by Kb is equal to what it would be? Kf by Kb is equal to concentration of B divided by concentration of A. Concentration of B divided by concentration of A. Okay. Now listen, this Kf by Kb is a new constant. This is not going to change. This ratio we call that as equilibrium constant Kc. For this particular ratio, we call it as equilibrium constant K, or you can even represent as Kc. No issues. Okay, so we can say that K is equal to Kf by Kb, which is nothing but B by A. What is that? B by A, we can generally write it as concentration of the products. Okay, concentration of the products divided by concentration of the reactants. Okay, this is how the derivation is coming. So I have explained it. Now you know one thing, K is nothing but what, sir? What is K? Tell me, sir. K is nothing but Kf by Kb. So what is given in this question? We will try to understand. So they have given the rate constant of the backward reaction, Kb value is given and the K value is given, and they are asking you the rate constant of the forward reaction, Kf you need to find. So K is 1.5, K is 1.5. So K value I need to substitute here, K is 1.5. K is 1.5 here, and Kf, so what is Kf value? So Kf, what we need to find it out, so we will put it here, Kf. And what would be Kb, sir? Kb is given as 7.5 into 10 power minus 4. So 7.5 into 10 power minus 4. Okay. So from this, how you can find Kf? Kf is equal to what? 1.5 into 7.5 into 10 power minus 4. So sir, it's a matter of classification, just calculation, we will do it. So 3.5 we will do it as 3 by 2. 7.5 we can write it as 15 by 2 into 10 power minus 4. So 15 into 3 is 45. 45 divided by 4 into 10 power minus 4. So how much it will become? Somewhere 4 into 4 by 44 is 11. So 45 by 4 is 1 point. We can write it as 11.2 into 10 power minus 4. Or we can write it as what? 1.12 into 10 power minus 3. This would be the correct answer. Okay. So where the answer is present, 1.12 into 10 power minus 3. Yeah, here we have the option, that is option 3 is the correct answer. So if you know the equation or if you know the fundamental, it will take a maximum of 10 seconds to complete this question. So I am trying to explain you the concept, and along with that I am trying to explain you the answer, so that you will get a clear clarity of what you need to do. Okay. So I hope it is clear for you. So let's switch to the next question. So I know this is a time where students are finding little much lag. So you know that the NTA has again come up with the notification. You know the date when the NEET exam is going to happen. It is on May 5th. That is the first Sunday of May. So please in your room, you please put the remaining number of days and work very passionately, so that each day you need to learn something new and try to become master of what you are learning. So if you keep accumulating days similar to like that, so on May 5th you will be completely confident to crack NEET. So in Brainiacs classes, we support students, we motivate them, we will make them eligible to become very good doctors. Okay. So those students who are feeling lack of energy, they may feel lethargy, please feel free to contact Brainiacs classes. We are in complete support for those students who want to become doctors. Okay. And we will give you all important questions, everything would come from our material only. Don't even worry about even learning an extra single question. Okay. So let's start doing the next question. So here in this question, they are asking Kp is how many times equal to Kc for the given reaction. So earlier I have told we have equilibrium constant K is present, correct? I hope you remember. So K is there. So the equilibrium constant K is present. So this K we can classify into 2. This K we can classify into 2. Depending upon whether the pressure is considered or whether the concentration is considered. If pressure is considered, we will call that as Kp. Okay. And if concentration is considered, we will take that as Kc. Now students will ask, sir, why pressure we are taking, sir? What is the fundamental behind that? Many students have doubt. So I will explain that concept. Okay. So let me say K is classified into Kp and Kc. Okay. Kp and Kc. So what is the fundamental for that? So we know that PV, we have equation PV is equal to nRT. This is the fundamental gas equation for ideal gas. So this equation can be rewritten as P is equal to N divided by V into R into T. Okay, here N divided by V is what actually, sir? N divided by V, that is number of moles divided by volume. That is nothing but concentration of whatever it is. Let me say the reactant is A, then I can say it is concentration of A, and I can write that as PA. That then this will become partial pressure of A. So I can rewrite this as this is concentration of A. Okay, this is concentration of A into R into T. Now we know that the whole reaction happens at a specific temperature and R is a constant. In that case, we can write pressure is directly proportional to concentration. Pressure is directly proportional to what, sir? Concentration. So that means if concentration is not given and if you know the pressure of that particular reactant, then we can even use pressure there. So in that case, if pressure is coming into picture, we use the term Kp. Understood? And if concentration is coming into picture, we use the term Kc. Hope it is clear for you why we are using Kp and Kc. Okay. Now even I can write a general equation and show you how for fundamentally we write it in terms of pressure also. Okay, so let us consider a general reaction AA, okay, plus BB, okay, and this is giving you a reaction or product like a CC, okay, CC. Let me say only up to this, or we can write DD as well, okay, DD. Okay, and assume that all these are gases. Please remember, gases, these are only valid for gases. If solids and pure liquids are there, you need to take that as unity. Don't forget that. Okay, so how will you write Kp, sir, for this one? So Kp can be written as Kp is equal to, now we write partial pressure of, or the pressure of C whole raised to, tell me, sir, whole raised to, what is the coefficient? Coefficient is C, and partial pressure of D whole raised to, what it will come? Whole raised to its coefficient, that is small d, divided by what it would be? Reactant, that is partial pressure of A, okay, whole raised to, the coefficient is what? Small a, divide into partial pressure of B whole raised to B. So earlier I have shown you how to write Kc. So this is how Kp is written. Now here in this question, they are trying to link Kp and Kc. So I am not going to derive the relation between Kp and Kc, but please remember how Kp is related to Kc, sir. Kp is equal to Kc, okay, so Kc into RT whole raised to delta Ng, okay. This is the fundamental equation you need to remember to handle this question. Okay, very important. Okay, so very simple, sir. Here delta Ng is what? That is very important and important to understand. So please remember, delta Ng is the number of moles of the reactants, number of moles of the products minus number of moles of the gaseous reactants. Very important, gaseous product it should be. So gaseous reactant, okay, and this should be gaseous product. Only gaseous stuffs we will consider. Okay, yeah, so this is gaseous reactant and this is gaseous product. Okay, gaseous product. So this is simple and you should remember this. Okay. Now let's go to this question. In this particular reaction, what is the number of moles of the gaseous products, man? So you can see here number of moles or stoichiometric coefficient of the product is 2 moles of product are there, and number of moles of the gaseous reactant, this is gas and this is gas. So 3 plus 1, here 1 is the coefficient, so 3 plus 1, 4 is there. So I can write the delta Ng is equal to, delta Ng in our case is equal to what? Delta Ng is equal to 2 minus 4. Okay, so 2 minus 4 means the value would become minus 2. Now you can substitute here. So this would become Kp is equal to Kc into RT whole raised to minus 2. Now how you can write this further? You can write it as Kc into 1 divided by RT the whole square. Okay, this can be further written as what, sir? This can be further even written as Kc times 1 divided by R square T square. Okay, so I can say Kp is 1 by R square T square times Kc. So this should be my correct answer. I hope it is clear for you. Okay, any option like that? Yes, option 1 is present very clearly. So let my answer is option 1 is my correct answer. Okay, so I hope you understood the concept of Kp and Kc, how to write Kp and how Kp and Kc are related. So please remember here this gaseous has very important meaning. If the reactant is not a gaseous reactant, we will not consider its number of moles. Okay, that is the most important point to remember. Okay. Now let's start doing the next question. So I hope all of you could see the question here. Okay. The question given here is 4 gram hydrogen. Okay. 32 gram oxygen, 14 gram nitrogen, 11 gram carbon dioxide. All these are taken in a 500 ml bulb. Okay. And they are asking which one of these have maximum active mass. So very important, don't get afraid with the term active mass. Active mass is same as concentration, and this concentration is nothing but molarity is what we take normally. So please remember active mass I will define first. So active mass is equal to let me say number of moles divided by number of moles of that substance divided by the volume it occupies. So this is represented as in square bracket. This is usually represented in square bracket. So this is same as concentration. Don't worry about that. So let me say if I want to write active mass of A, then how will you write it? Active mass of A is equal to, similar to concentration of A, we will write it like this, equal to number of moles of A divided by volume it is occupying, V. So this is how fundamentally we define active mass. So what is its unit? Its unit is what, sir? Mole. Mole is at the numerator, and in the denominator we have volume, that is liter. So we can say mole per liter, which is the same as the unit of molarity. Clear? So I hope you understood what is active mass. Now they are asking which one of these have maximum active mass. So let me take one by one. First we will do the active mass of hydrogen. Okay. So the active mass of hydrogen is equal to, how it would be, sir? Active mass of hydrogen is equal to how much? Okay, so the number of moles of hydrogen, we need to know number of moles. So number of moles can be further written as what, sir? You might have learned in our first chapter, number of moles is equal to weight in gram divided by molar mass. Correct? This is how the number of moles is defined. So we can use that. So weight in gram, don't get confused. This is weight in gram. Okay, here let me write that first. So weight in gram divided by molar mass. Okay, this is my number of moles divided by, we have volume in the denominator. We have volume in the denominator. Okay, volume in the denominator. So they say 4 gram hydrogen. So 4 gram hydrogen means, how will you substitute, sir? So 4 gram hydrogen. So we have 4 divided by, weight in gram is 4. Then molar mass of hydrogen, H2, hydrogen gas, it is 2. Divided by what it would become, volume 500 ml it is given. So that is 0.5 liter. We need to express it in liters. So 0.5, that is 1 by 2. Okay, so the answer would be what? 4 by 2. This is 1 divided by 2. So 2 will come in the numerator. So it is 4 mole per liter. Okay, 4 mole per liter. Now similarly you can find out active mass of the other one. What is the next? Next is 32 gram oxygen. So let's try to do that little fast. So 32 gram oxygen. So the active mass of O2. So we can write it as, so 32 gram, I am not repeating the formula. So 32 divided by O2. What is the molar mass of O2? 16 into 2, 32. So 32 by 32 divided by 0.5. So cancels it out and this will become 2. This is 1 by 2. So 2 will come in the numerator. So that is 2 mole per liter. Correct? And what is the next one? We have 14 gram of nitrogen. Okay, so we need to find out for active mass of nitrogen, N2. So how will you write it, sir, again? Okay, 14 gram. So 14 divided by N2, molar mass 28 divided by 1 by 2. So we know that numerator is 1 by 2, denominator is also 1 by 2. So that is 1 mole per liter. Okay, and the last one, 11 gram carbon dioxide. 11 gram carbon dioxide. So for carbon dioxide, similarly we write it like this. Active mass of carbon dioxide is equal to 11 divided by molar mass of carbon dioxide, 44. You should remember this. Divided by 1 by 2. Okay, so this is nothing but 1 by 4 divided by 1 by 2. So 2 will come in the numerator and this will become 0.5 mole per liter. So tell me, sir, it's an easy question. So we know that among this the highest value is for hydrogen. So my answer would be, hydrogen would be my correct answer. The highest active mass. But in sometimes the question they may give you to find out the minimum active mass. So always be careful of what is the terms that are used in the question. Okay. Very much clear for you, I hope. Okay. So let's start doing more questions. So we have the next important type of questions here. This type of questions mainly gives you an idea regarding the factors that is affecting the equilibrium constant. We know that the only thermodynamic parameter which affects or which changes the K value is temperature. But other than this thermodynamic parameter, for example, if you reverse a reversible reaction, the K value changes. If you multiply with a particular value, the K value changes. Divide with a particular K value, it will change. So considering those things, these type of questions will be asked actually. So let's try to understand the question. Okay, I will explain it in detail. Don't worry. So we have the reaction. Reaction given here is 2A plus B giving 2C. For this particular reaction where A and B are the reactants and C is the product, equilibrium constant K is given as X. K is equal to X. Now they are asking you for another reaction, that is C is the starting reactant and that gives you A and B. What is the equilibrium constant? So in this type of question, they are asking you to find out the equilibrium constant of a new reaction. But please check with this new reaction, all the reactants and products are present in the given reaction. Here for example C, it is here present. A, it is also present here. B, it is also present here. That means if you modify this reaction, you can get this new reaction. So what modification we are doing, that is what is important. Okay. So let's try to do that question and try to understand. So here the given reaction is 2A plus B, 2A plus B. Okay, you can see here 2A plus B giving you 2C. 2A plus B giving you 2C. And for this, the equilibrium constant K is given as X. K is given as X. Now we want to convert this reaction to this particular reaction. For what and all mathematical things we need to do it. So we know that in the new reaction, this C is coming as a reactant. So this here it is a product. So we need to reverse this reaction. So if you are doing a reversal of the reaction, so let me mark this as equation 1. I will say mark it as equation number 1. Okay, so reverse equation 1. Reverse equation 1. So we know that on reversing, the equation will reverse and you will get it as 2C giving you 2C giving you what? 2C giving you 2A plus B. Now the important question is, if you reverse a reversible reaction, what happens to its equilibrium constant K? So please remember, if you are going to do a reversal, the equilibrium constant will go a reciprocal. So I can say the new equilibrium constant, let me write it as K dash, would be what? You have done a reversal, so we need to take the reciprocal of the existing value. So this will become 1 by x. So please remember, whenever you are doing a reversing, the equilibrium constant will get reciprocal of the existing value. Okay, I hope it is very clear. This is something rule you need to remember. Or you can do write the equilibrium constant and you can see it. But you should remember this. That's how you can save time. Okay, now what else you need to do? Convert this to the required reaction. In the required reaction, C has the coefficient 1, A has the coefficient 1 and B has the coefficient half. So you need to divide by 2. You need to divide by 2 so that this will become our expected reaction. So let me mark this as, let me say equation 2. Let me mark this as equation 2. Okay. Now you can say divide equation 2 by 2 by 2. Okay, so you are going to divide it. So on dividing, this will become C. Okay, this will become C. Okay, this will become C. And this will become A. This will become A plus this is half B. Half B. Now we got the expected reaction. Now in this case, what will happen, sir, if you are doing it? So please remember, when you are dividing by any number, this will become the whole thing raised to that particular stuff. Okay, it will be 1 by delta ng, it would become. Okay, so for example, here it will become like K double dash. Let me say this is K double dash. This is the existing value 1 by x. Now what is the new value? When you are dividing, the whole value will become 1 by divided value. What is the 1 by divided value? That is 2. 1 by 2. Or we can write K double dash is equal to root of 1 by x. Root of 1 by x. Or we can say K double dash. Or we can say K double dash is equal to 1 by root x. This would be the equilibrium constant of that particular reaction. So what you need to remember? 3 things you need to remember. If you are doing a reciprocal, if you are doing a reversing, take the reciprocal. And if you are multiplying with something, then the new equilibrium constant K dash will be what? the old equilibrium constant raised to that particular value. If I am multiplying with n, then it would be k raised to n. And if you are dividing, then what will happen? It would become that value, old value, all raised to 1 by n. What is that number? That would be. Okay. So this is the case of multiplying by n, multiply by n. This is the case where dividing by n, divide by n. Okay, here it was division, so that's why I have written 1 divided by what? 1 divided by the divided number, that is 2. Hope you understood. So please remember, sir, what we have done here. They have given a reaction and they know its equilibrium constant as x. Okay, and they are asking you to find out the equilibrium constant of a new reaction. So from this reaction we need to convert, or we need to do mathematical operation and convert this to this particular new reaction. So what are the mathematical operations basically we done here? Reversing. On reversing, the equilibrium constant will become reciprocal. Then what is the next mathematical operation we have done? Dividing by 2. On dividing by 2, the value will become 1 by n. So that n is the divided number. So you got the answer. Okay. So where it is present in the options, option 3 would be the correct answer. Option 3 would be my correct answer. I hope you are getting it. Any doubt, feel free to ask in the comment box, or even you can call directly to the number that is shown in the display. Okay, you will be added to our WhatsApp doubt group and you can ask your questions there itself. Okay, yep. So shall we go to next question? Yeah, so we can move to next question. So the question given here is very, very important. So yeah, so they have given a dissociation question. So let us read the question. The question is xy2 dissociates as xy plus yg. Okay, this is how it is getting dissociated. Now they are telling the initial pressure is given. I told you, right? Even they can give you concentration or even pressure. Okay, so the initial pressure is given as xy2 have an initial pressure that is 600 mm of mercury. Now they are telling after that the reaction has went off and it has reached equilibrium. Now the total pressure at equilibrium, now they are telling it has increased to 800 mm. Now assuming the volume of the system to be constant, the value of Kp is what they are asking you to find out. So how you can do this, sir? So let us try to write the question again. So that is xy2. Okay, so you have xy2. Okay, so the reaction is xy2 getting converted to what, sir? xy2 getting converted to xy and y. Here please remember it is a gas. This is also a gas and all are gases. So all these will come in our Kp equation. Okay, now how to solve this question? So they are telling initial pressure is 600 mm. So let us write at a time t is equal to 0. At a time t is equal to 0. At a time t is equal to 0. We say the initial pressure is 600 mm. 600 mm is the initial pressure. Now we know that initially there are no products. That is when the reaction has just started. So there is no pressure that is caused by xy and there is no pressure that is caused by y. Okay, so this pressure would be 0 mm. Okay, now we know that the reaction has started. So when reaction has started, let us assume some of the xy2 has converted to xy and y. So let me say 1 unit of xy2 on reaction, it gets converted to 1 unit of xy and 1 unit of y. Correct? 1 unit of y. So let me say P unit. Okay, pressure is P. Okay, xy2 pressure P unit has changed to xy. So it will create what actually here? It will create a 1 unit of pressure here and 1 unit of pressure here. So let us assume 1 mole of xy2 now converted to 1 xy and 1 y. So 1 xy2 is now converted, almost converted. Okay, 1 unit is now converted. What does that mean? That means that 1 unit has a pressure P. Let us assume that 1 unit has a pressure P. So that is now converted to product xy and P. So this xy will also now produce a pressure P, and this y also will produce a pressure P. Now this pressure will now decreases from this unit. Why? Because now 1 mole is less. 600 is for the entire given unit. From that 1 unit, let us say it is converted to this like this. Why I am taking 1 unit? Because in the stoichiometry it states that 1 unit on converting it will become xy and 1 unit y. So let us assume there are p units are there. I don't know how many have converted to product. So that's why I am assuming p units are there. So if 1 unit generate 1 mm pressure, then p unit will generate how many pressures are? P mm pressure. Okay, so I will write it here for you to understand. So below I will write 1 unit will generate P mm pressure. 1 mm pressure. Let us say 1 unit has 1 mm pressure. Suppose there are P such moles are there. P moles are there, then that will generate how much amount of pressure? P mm pressure, multiplying by P on both sides. Okay, so here let us assume P units have been converted to xy, and so how many units of xy would be generated? P, and here P units would be generated. So that will generate P mm pressure here. So what is remaining at equilibrium? Now we will take at equilibrium. At a time it reaches T time equilibrium. Now we know that this P mm pressure would be less here because that has converted to product. So I can write it as 600 minus P, and here that much units are there, so that will generate P mm pressure here. So P, here also P. Now we know this case at equilibrium what is the pressure out there. Now they are saying total pressure at equilibrium. So the total pressure they are saying at equilibrium. Total pressure at equilibrium they have given as what value, sir? They have given that as 800 mm. Okay, so we know total pressure at equilibrium can be found out by how? Adding 600 minus P plus this value, because at equilibrium these are the units that is present actually. So we are adding that. Okay, so we are adding 600 minus P plus P is equal to 800. Okay, so P cancels, so this will become 600 plus P is equal to 800. So from that I will get P is equal to 800 minus 600, that is 200. So I can easily say 200 units have been converted before it has reaches equilibrium, because here P we have assumed, right? Now we need to find out Kp. So how will you write Kp, sir? Kp is equal to, we know that product is xy whole raised to 1. Okay, so since Kp we need to find out, we should write not like this. We should write it as pressure given by xy whole raised to its stoichiometric coefficient, that is 1. Then we have pressure generated by y, and we should generate its value coefficient as 1, divided by pressure generated by xy2 at equilibrium. Its coefficient is also 1. Okay. Now let's substitute that value. Tell me, sir, P pressure at xy at equilibrium, 600 minus P. 600 minus 200 is how much? 600 minus 200, it would become 400. This is 200 and this is also 200. So xy is 200. I can write it here, 200 into y is also 200 divided by pressure of xy2, that is 400. So you can cut it as, so this will become 2, so the value would become 100. Correct? The value would become 100 and we have the option 2 as the correct answer. Okay. So I hope it is clear for you. If you have any doubt, you can ask. So I am explaining it one more time for some students. They may got some doubt. I will explain it. Very simple, sir. Initially, XY2 has a pressure 600 mm. That is at a time t is equal to 0. Okay. Now, before it reaches equilibrium, some units of XY2 has been converted to XY and Y. We don't know what it is, how much units. So let us assume there are P units gets converted to like this. So for doing that, from stoichiometry, I know that 1 unit of xy on conversion will give me 1 unit of xy and 1 unit of y. So we are assuming here P units are getting converted. So what will happen? So P units of xy2 on conversion will give you, here I am multiplying with the P. So here also you need to multiply with the P. Here also you need to multiply with the P. So I can say Pxy2 unit on conversion will give you Pxy unit and Py units. Okay. Now we know that, let us assume 1 unit has a pressure of 1 mm. Now we know that P units have been converted. So that will have how much mm? P mm. So that's why here P mm is written. Okay, so this P mm units now converted, or P mm pressure is now decreased from reactant here, and that is coming here as P mm. Why P mm is coming here? Because Pxy units have been generated and Py units have been generated, and the pressure of that is written as P mm and P mm here. Okay, now this much pressure is decreased from the reactant, that's why 600 minus P is coming here. Okay, so here that much pressure is increased, so that's why P is coming here. Now you can, it's given in the question, at equilibrium the pressure is 800 mm. So total pressure, is here generated by 600 minus P and this P and this P, because these many units are present in the medium. So adding this is equal to 800. So from that we will get P value, then substitute here, then you will get the actual pressure caused by these particular molecules at equilibrium. Substitute in the Kp value, then you will get what is Kp. Okay, I hope you understood. So this is our part 1 of the chemical equilibrium series, and there will be part 2 on the next week. Okay, so please tune to our channel. Those who have forgot to subscribe our channel, please subscribe it and put a like button if you have liked the explanation. Okay, so we are coming with more chapters. So next week also chemical equilibrium part 2 would be there. There we would explain more questions of this type, and we will also come with Le Chatelier's principle and other important questions, and we will wind up chemical equilibrium. So please, one more time, I am requesting all the students, all these questions we are going to solve only. So please tune to our channel. So please remember the name Brainiacs Classes. It is located in Coimbatore. You can watch Google or YouTube, wherever. We have the complete classes in YouTube channel. You can go to our YouTube channel. Okay, go to the playlist. Whichever chapter would you like to see, you can go and see it. That is present there. In addition, if you are if you need an offline class, you can directly call to the below number. So there you can join. The cost is very much affordable. So we are giving a quality education. All our teachers are from Kerala, from reputed institutes, and they have 15 or more years of experience. And surely I can make you the whole classes is in English only. So surely you will understand. There is no worry like you will not understand, and we are in complete support for you guys to become great doctors. So signing off, thank you. So we will see next Sunday at 4 p.m. Bye.